So for this lesson, we're going to look at graphing equations that are in the form y equals mx plus b. So we'll see what that involves and how we can do that efficiently. Okay, so we will take a look at this first example of just graphing something using a table of values. That's how we've graphed before. So in this, we have the equation y equals 2x plus 3, or 2x minus 3. And what we've done in the past is to find out the y values, we simply take our equation. Where x is, we replace it with the particular number that we have. So -1 for the first one in the table, -3. And then you calculate this out. So 2 times -1, that's -2, minus 3 is -5. And then place that number into your table of values. All right, next we do the same thing, but now we just use the next number in the table. So next is x equal to 0, so 2 times 0, minus 3. 2 times 0 is just 0. Minus 3 is just, well, minus 3, or -3. Continuing on, y equal to 2 times 1 minus 3 is going to be 2 minus 3, which is just -1. And lastly, you have 2 times 2 minus 3. 2 times 2 gives you 4, minus 3 is 1. And there you have your table of values. So we can write this table of values as a set of ordered pairs. So you have the first point is -1, -5. So again, we're just taking a look at the two x and y values beside each other. So what's the corresponding y value with the given x value? And that makes your point. Next, you have 0, -3, 1, -1, and 2, 1. Why did I list these ordered pairs out? Because these are the things that we're going to graph onto our graph to the right there. So we'll do it in purple. So all these 4 points, we're going to plot down. So -1, -5, so down or left 1, down 5. 0, -3. 1, -1, so across 1, down 1. And 2, 1. And there we have it. That is our graph. Well, the start of our graph. Next, what we want to do is, since this equation is a line, we want to connect these points all with a line. And if you use a nice straight ruler, you can connect them up in that kind of a way. And so this is the graph of y equal to 2x minus 3. That's how we would have done it using our past techniques of a table of values. Now we're going to see that there's actually going to be another way we can do this. Okay, so let's remind ourselves of mx plus b form. So what do m and b refer to? Well, m, this is the slope of your line, and the b, this is your y-intercept. So, for example, in the equation that we were just looking at, the 2 in front of y equals 2x minus 3, that would mean we have a slope value of 2. And the minus 3 part, that would mean we have a y-intercept of -3. And we use the letter b for y-intercept to represent that. Okay, let's see how we can actually make use of those two values to graph our line. So the general technique that we can use is we can actually graph something in this particular form, so in y equals mx plus b form, by first of all using the y-intercept, so the b value, and plotting that onto our graph. Then you can make use of the m value, because the m value will tell you basically how you can go from one point to another point on that particular graph using that slope. And lastly, once you have 2 points, since it's a line, it'll have that constant kind of shape throughout the whole line. So you can just draw a line connecting those 2 points and extend it as far as you can on the graph. So let's take a look at how we could do that. With the same equation, we're just going to see how we can do it a little more efficiently now. So again, let's identify the y-intercept. We said that was -3, so that's the value at the end. And the slope, that is 2. So the first step told us that we need to plot down the y-intercept. So the y-intercept, that's going to go at -3, so y-intercept. So that's step 1. Step 2, take a look at your slope. We have a slope value of 2. Remember, slope is equal to rise over run, and that's what we're going to make use of to figure out where could a new point be. So if we have rise over run, that's kind of 2 is like saying you have 2 over 1. So we're going up 2 and across 1 as we go from point to point. So up 2, across 1. And that would be a new point. So rise, run. 2, 1. Okay, we have 2 points. So now we can simply join those 2 points together and draw a line using a ruler that connects them together. And you'll see I always add arrow points at the end of these graphs, and that's just to indicate that this line it's going on forever and ever. It's not stopping when it reaches the end of our graph. It keeps going on and on. But just like that, we were able to create a graph. So with just 2 pieces of information directly from that equation, we can very efficiently make a graph without having to use a table of values. Okay, so let's try it again with one that we haven't previously graphed. So we have y equal to -1/3 x minus 1. Okay, so first of all, let's identify our key values. So the number at the end, the -1, that makes our y-intercept. The next value, -1/3, that makes our slope. So we have those 2 values. Now let's go ahead and create the graph. Okay, so starting things off, we start with our y-intercept and go to -1 along your y-axis. So again, I'll just label it for us just so we remember what it is. So this is the y-intercept. Okay. Then, using that slope, -1/3, so remember that this would mean a rise of -1, a run of 3. We can find a new point on the graph. And remember, if you have a negative rise, that just means you're going down. So you're going down, that's our rise, -1, and we're going across 3. So that's our run. And that leads us to this point over here. Once you have 2 points, theoretically, you could keep doing this pattern of rise over run. So you could go down 1, cross, find another one. You could even go backwards. So back 3, up 1. And there you can see we're getting lots and lots of points just very efficiently like that. The main idea, though, is once we have 1 or more points, we can go ahead and join that up in a line. And again, I'll add arrow heads to the end of that line to indicate that's going on forever and ever. And so this makes the line y equal to -1/3, or 1/3, x minus 1. All right. Now let's go backwards. So what if we have graphs? Let's just remind ourselves of how to get the equation of the graph. So we'll just go in order A, B, C, and D. They're a little faint on here, but A is this one here, so I'll draw it in red. I'll go over it in that. And then let's identify the key information. So first piece of information, we're going to write all of our graphs in y equals mx plus b form. So I'll already write y equals. We can see where does it cross the y-axis. And you can see it's basically 1 up from 0, so it's going to be at plus 1. Next, we need to see what is the slope. So what is the rise over run? Well, let's just look at any part where it nicely goes over the grid, and then see where's the next point where it nicely goes over the grid. In this case, you can just go down 1, across 1. So down 1, across 1. And so that would actually mean your m value would be, well, -1 over 1, which is just -1. So if we write this equation down, -1 is the same as just writing -x plus 1. And there we have our equation of the first graph. Let's take a look at the second graph. So the second graph we'll draw in this greenish color. Just go over it there. And again, we're crossing at the same point. So our y-intercept again is going to be b equal to 1. This time we can see it's a little steeper, so let's see what the actual rise over run is. So we'll start at our y-intercept, so we can use that as a point on our grid, and we can see it crosses down here as well. So to get there, we can go down 2, and across 1. So we're going down 2, across 1. In terms of a slope, that would be -2 over 1, which is the same as just -2. So we can write this as -2x plus 1. All right, what about some other graphs? Let's use some other colors here. So we'll look at C. We can see that it crosses the y-axis down there, and that's basically 1 unit down from the origin. So because of that, we can get a y-intercept of -1. What's the slope going to be in this case? Well, let's find out. So the slope, I'm going to use like darker purple. We'll start here, and you can see the next point that neatly aligns between 2 grid points is there. And you can see in this case that we go up and across. We go up 3 units and then across 1. So that's up 3 and across 1. And so in terms of a slope, that would be rise of 3 over a run of 1, which is the same as just saying 3. So y is going to be equal to 3x plus or minus 1 because we have a negative in front of our y-intercept. One final example. We'll do this in this color here. D is this one here. And the y-intercept in this case, I just want to get it so that the line is much straighter. It's way down here. That's the y-intercept there. That's at about -4, I'd say. So we can say b is equal to -4. What's the rise over run going to be in this particular case? Well, let's take a look. So let's start from the y-intercept, and let's go across 1 and up 3 to the next point that's sitting about there. So +1, up 3. Just remember, you write down your rise first, so you're going to go 3 over 1 across, which is the same as 3. So it actually has the same slope as the one we just wrote. And we'll actually look at parallel lines in a future lesson. But this time, 3x, now it's going to be -4 since our y-intercept is further down. All right, and that's a look at making graphs using that slope y-intercept form, as in y equals mx plus b, and then also reversing that given a graph, finding out what that equation is.